Okay. Okay. So good morning, students. We are here today for an expert session on non-linear data structure. It will be conducted by Professor Lata More. She is an assistant professor in JSPM College of Engineering, Pune. And she is pursuing her PhD from the same institute. Her area of interest is image processing. So I hope you will be benefited from today's session. She will be conducting your session on the topic of nonlinear data structure, and that is trees. So in nonlinear data structure, we have already started with the topic of graph. This is the second concept of nonlinear data structure, which she will be introducing to you. So I hope you will be attentive for this session. And thank you, madam, for accepting our invitation on such a short notice. Shall we begin?
Yes. Okay.
Okay.
Thank
Okay.
you, ma'am.
Over
Thank
to
you
you,
for the
madam.
nice introduction. Good morning, students. Now here I am to introduce you about the non-linear data structure, and especially today I will focus on the topic of trees. So I hope you all enjoy the session, and instead of enjoying, I can say that you will be benefited with this session. So I am starting with this, as madam already introduced. I am myself Lata More. I'm working JSPM RSCOE, and today my topic is non-linear data structure. So if any issue is there, presentation is not visible, I'm not audible, then please let me know. So here in today's session, I will explain you about, means I can say as the content of today's session are non-linear data structure, introduction to trees, basic terminologies, binary tree, binary search tree, traversing a binary tree, and application of trees. So at the end of this session, you all will be familiar with all these terms. So let us start with the introduction of data structure. Basically, we can say as data structure is nothing but a collection of data. And instead of collecting the data, we can say that we have to organize the data in a specific manner. And to organize the data, it can be classified as linear data and non-linear data. Till now, in linear data, you have studied about array, stack, queue, and linked list. And for non-linear data structure, now you are going to study about graphs and trees. So as all these terms are very familiar with you and you all know about this is nothing but just I can say as about the linear data structure. First of all, I can say it is array. Already you have studied about array, you have performed different experiments on array. So we can say as array is nothing but a collection of elements of the same data type and store them in a contiguous and adjacent memory location. Here you can observe that this is nothing but an array. For this array, you can see as these index are provided and by at particular index, a particular data is stored. Now in memory, specific location is given for that. And you can see that the memory location is a continuous. And as we can say as here in this data structure, 6 values are stored. So the indexing is from 0 to 5. Next is nothing but stack. For stack, you can say as this follows the linear, that is LIFO. It is a linear data structure and it is last in first out. So in this diagram, you can observe that here these two are the stacks. In stack A1, A2, A3 data is stored. Here using push, you can enter the data. Using pop, you can retrieve the data. You can remove the data. Then next is nothing but queue. So this is again one of the linear data structure where it is open on both the ends and the operation are performed in first out order. Last is nothing but linked list. For linked list, it is collection of data element whose order is not given by the physical element in memory. It is the data structure consisting of collection of node which together represent a sequence. Basically, C students, I can say as in case of linked list, here this is a node and this node gives address of the next node. So as I said, in case of array, the continuous memory location is required. This is not necessary in case of linked list. Maybe already you have all studied with this. Now, as the today's topic is more focus on non-linear data structure. So these two are the examples of non-linear data structure, that is tree and graph. Here you can observe the representation. You may see that these two diagrams looks the same, but we can say as even though this particular block here you can see as A, here is also A. So these are nothing but the nodes. But to call them in case of a tree and for the graph, some difference is there. So that we have to discuss. Now, when I'm saying about tree, it is nothing but a non-linear data structure. Basically, students, you can observe that when I'm saying as a linear data structure, for linear, I can say as a continuous memory is assigned, and even though continuous memory is assigned, with that, the data is arranged in a specific manner. In case of non-linear, you can observe that the data is not sequentially mannered. Here it is not the sequential representation. That's why it is called as non-linear. So non-linear data structure represent the hierarchy. Hierarchical representation, step by step representation is there. So it is nothing but collection of nodes that are linked together to form a hierarchy. Hierarchy represents tree. And here you can observe the graph. Now you can see that same number of nodes are there in case of graph and in case of a tree. But in case of a tree, you can see that if I start from A, I comes to B and C. And here, this is, I can say as the grandparent, these are the parent, these are the child, and these are the grandchildren. But in case of graph, it is not the situation. I cannot say any of the node is the first one. I can, if someone thinks that you have to start from A, it is allowed. If someone thinks that no, I will start from E, then again fine. So this is nothing but a graph. So I can say as graph is nothing but a tree data structure, or it is a collection of objects of entities known as a node, and each node is connected through the edges. So here graph is represented as vertices and edges. So combination of vertices and edges is a graph. Already you may have studied about this also. So as my role is there, I have to focus on these. So students, observe this diagram. Everyone has seen the tree. The tree which you have seen, the exact inverse tree we are using in data structure. See here, this is the representation of tree. This is the tree that already you have seen. This tree have roots, this tree have branches, this tree has fruit, this tree has flower. Now don't focus on all these remaining terms. Mainly we are focusing on the 4 basic terms of the tree. I can say as it is having root. So similarly, our data structure tree also have a tree. The thing you can observe that just I have inverted the tree, that we are observed everywhere. So here I have reversed the tree. So the roots are the first part, I can say. Similarly, for data structure, root is the first part. Then comes the branches. These are the branches. Similarly, I can say these are the branches. And in case of data structure, I have to call these branches as edges. So root and root connected with the branches. So for this, now you can observe the leaves. As these leaves and fruits you can see, so I can say as the leaves are nothing but these nodes. So for the leaves in case of tree, for data structure tree, that leaves I am representing with the word as node. So root is same as root is same as root. Branches I'm calling as edges, fruits and leaves and flowers. All these are called as the nodes. Now see, we can say as these are the first nodes, so I can call these nodes as the flowers. Then from these flowers, it can be converted into fruit. So the next node I can call as the leaf node. So see, here whatever these outputs means, the leaves, the flowers, the fruit, all these I am calling as the node. So see, from this diagram, I think it is clear to you all that what is the tree. It is not a big task to understand the tree, because simply whatever tree you are observing, in similar manner, the tree is represented in case of data structure. So for this tree, here is the root. These root connected with the next nodes using these branch called as edge. Again, as this is the tree directly connected to root, I can call this as a parent node, and these parent node have some child node. So, and these child node and again have this type of node. So you can say that here this G and H are the leaf node. So don't be confused. In detail, I will explain you about all these terminologies of tree. So I think from this slide, it is more clear to you that how the tree is represented in data structure. Now let's move to the next part. So now whatever till now we have discussed, that is just the basic idea, introduction of the tree, I can say. Now we are moving to technical language. So in technically now we have to see about tree. So I can say as tree is nothing but an abstract model of a hierarchical structure that consists of node with a parent-child relationship. So here, if I observing this, you can see as the parent is there, parent have number of childs, means children are there, and accordingly in hierarchical manner, the tree is organized. So tree is a sequence of nodes. The starting node is called as root, and every node other than the root node has a parent node, and that nodes may have number of children. So if you observe these two examples drawn over here, in the first example, I can say as this is the root node, means the parent. So for this parent node, number of children are there. That is nothing but B, C, and D. So A is parent of B, C, and D, and B is parent of E. Here again, this is the another example. In this example, A is the root node. Here, using this line, that is age. That age means I have to move from A to C. That is also called as the path. So this is the root node connected with these two nodes with the edges. They are called as the parent node. Now you can see as from root to first. So it is nothing but level 1. Root is at level 0. Then here you can see as D, E, F, G. They are represented or they are at level 2. And last means this is nothing but at level 3. So B is parent of D and E. You can observe here as A is parent of B and C. This B is parent of D and E. So again, this D is having one child. Now again, you have to focus where the child or where the we can say as where the nodes, child nodes are placed, and accordingly it can be called as the left child or right child. So again, in more detail, I can see about the terminologies. So see students, these are basic tree concepts or the terminologies that are used for representing a tree. So in this diagram, you can see as here, these are the basic tree concept. Root is nothing but node at the top of tree. Root is the node at the top of tree. Now you are very familiar with the term as tree. So if anyone says as tree, then for data structure, you must consider about in your mind, there must be this type of structure. So the first one, the starting node is called as the root. Now, next is the parent. Any node except root node has one edge upward to a node called as parent node. So what is explained over here? Any node except root node. So this is the root node. Without these, I have to focus on remaining all this. So when I focus on all remaining all these, they are having one edge upward. So you can see this is called as parent when it is having one node upward. These are also the parent. If they are having one node upward, these are the parent because they are now they are not having parent because they are not having any child nodes connected over here. So here in this diagram, you can say as this B is the parent node, C is the parent node, D is parent node, and E is parent node. Now next is child. Child is nothing but a node below a given node connected by its edge downward is called as the child node. So they are connected downward. So where they are connected with downward fashion, then it is called as the child node. So simply students, this is very basic terms that these are the parent, these are the children like this. Now sibling. So the child or the nodes, they are having common parent. So children having common parent is called as sibling. In similar manner here you can observe that these are nothing but the child and they are connected with the common node that is the parent node. So it is called as the siblings. Sibling means child of the same node. Now next is nothing but leaf node. So as I'm saying as the child node is also called as the leaf node. Node which does not have any child. They are called as the leaf node. So here you can see that these are the child. These are only the child. They are not parent. So these are means H, I, J, F, G. These are nothing but the leaf nodes. So students, these leaf nodes are also having another term as leaf nodes are also called as the external nodes. External nodes. Leaf node, external node represent the same thing. And here you can observe for these all remaining terms and remaining nodes like parent node. They are calling them as a parent node. So again, I can say that if I'm using the nodes other than leaf node are called as the non-leaf node. Non-leaf node are also called as the internal nodes. Now, in this diagram, you can see as A is the root node. On left hand side, it is having child B. On right hand side, it is having child C. But again, this C is the parent of remaining two. So this separately forms a tree. Here this B also forms a tree. D also forms a tree. So all these are nothing but the subtree. So I can say as subtree A represent descendant of a node. Descendant. Descendant means basically you can call it is nothing but any successor node on the path from that node to the leaf node. So they are having successor. That's why they are called as subtrees. Now, level. So, level of a node represents the generation of a node. Here you have seen level 0, level 1, level 2, level 3. This represents the generation. So, the level node represents generation of a node. If root node is there, this is at level 0. Then next child node is at level 1. Grandchild is at level 2. Grandchild is at level 3. In this way, we have to give the level. Simply, you can say that node in a specific line represents the level. So root is the first node. That's why they are at level 0. After this, we are having next nodes. They are at level 1 in similar fashion. Now next is key. Key represents a value of a node based on which a search operation is to be carried out for the node. So if for a node we have to find something. Now keyword is we are using key for programming. Key means now if you have performed the program to find search to do the search operation. So this in search operation mainly we are using key. So here any node for which we have to do the search operation that can be key. So in this tree diagram, if I told you to find out B, then B is the key. So this is about the different concepts. So in detail, we have to see about these concepts. So these are the generalized concepts, very easy concepts that we have studied till now. Now some deep concepts are also there. So students, I think that you all are getting me, and now we are moving to the next or the deepest part of the tree. So here you can observe as these are the basic tree concepts. Here first is degree of a node. You are now I'm explaining all these terms, and in your mind tree must be there. So if you are having notebook, pen, you can draw a tree, and accordingly you can means you have to get it cleared, or you have to learn from that particular tree diagram also. So here I am saying that first is nothing but a degree of a node. So degree of a node is the number of children of that node. For a particular node, for a parent node, depending on number of its children, it gives the degree of that node. Now what is degree of a tree? For a node, number of child for that node. So for tree, I can say the maximum degree of a node in that given tree is called as a degree of tree. So I can say as number of children of that node means maximum degree of any node in a tree is degree of tree. Next is the path. Path means it is nothing but a sequence of consecutive edges from source node to the destination node. So I can say that in the previous diagram which you have observed, see in this diagram, I'm saying that here this is the dotted line. This dotted line is the path. Suppose I have to find out the path for J. So to find out the path for J, I must start from the root node. So from root node, A to C, C to F, and then F to J. So this is the representation of a path for the data, or path for the tree. Now next is nothing but height of a node. So height of node is nothing but the maximum path length from that node to the leaf node. See students, I am saying that height of a node is the maximum path length, as in the previous diagram I told you, from A to B. This is the path length 1. Accordingly, we have to find out the complete length, and by finding the length, we have to find out the maximum path length. That is nothing but the height of a node. Then height of a tree is the height of root. When I am saying height of a node, it is for maximum path length from that node. And if it is taken for the root, it is called as height of a tree. Because root is the basic node. Now next is nothing but depth of a tree. So depth of a tree is a maximum level of any leaf in a tree. Now see, there may be some confusion between height and depth. So in detail, I will explain about this. See this diagram. In this diagram, you can see as this elaborates the height of a node. So height of a node is the number of edges, means the path, number of edges on the longest path from that node to the leaf node. So as such, the height of a tree would be the height of its root node. Meanwhile, the leaf node have height 0. See, I can say as for leaf node, height is 0. As I am saying that here, you can observe here, this height is 27. Data is 27 for this node. So for this node, height is 0. Here, these are again the leaf node. 15 is leaf node, 5 is leaf node. So for these two, height is 0. So I can simply now see, you have to remember it, or it means this must be clear to you. So in simple language, very basic language, we can say as starting from the bottom, it represents the height. Starting from the leaf node, as when we have seen here, you can see when I discuss about the level, you can see students over here. When I am saying about the level, here is the level, means root is at level 0. Means what I have done, I have started from root and moving to the leaf to find out the level. And here, when I am discussing about the height, I am saying that exactly opposite I am doing over here. I have started from the height. I have started from the leaf node and I am moving in the upward direction. So here for the leaf node height is 0. For these node height is 1. Here height is 2 and height is 3. Now see level for here in this diagram you can see that here is the root node. For this root node height is 3 because it is again said that height of a tree or the height of a root represent height of the tree. So here is the height of tree, that is nothing but 3. But when I am saying about these, so these two, both these are the children of root node. But you can see that here height is 1, here height is 2. Why so? All they are put at level 1. These two are at level 1. But we have to focus on the path to find out the height. To find out height, I have to focus on the longest path. So here this is the leaf at height 0. This is at height 1, at height 2, at height 3. So as such, the height of the tree would be the height of the root node. Meanwhile, the leaf node have height 0. So in this diagram, it is clear to you. I think it is clear to you now how to find out the height of a node. Now let's move forward. Next is nothing but depth. See, we have studied about level, we have discussed about height, and now I am focusing on depth. So the depth of a node is the number of edges from that node to the tree's root node. See, again here also I'm doing in the same as the fashion I have done for level. So I have started as the depth of a node is nothing but number of edges from the node to the tree's root node. As such, the depth of the whole tree would be the depth of its deepest leaf node. So again here also I have to find out the longest. Longest means deepest leaf node. So the root node has depth 0. Let's look at the following two, which gives you the depth. So here I can say here is the root node. Root node having its depth as 0. Next is nothing but these nodes kept at level 1 having depth as 1. These are the nodes kept at level 2 having depth as 2. And here is the last one that is having depth as 3. So students, it is now more clear to you that level of a node is nothing but the depth of a node. But level is not equal to height. Depth and level we are starting to count from the root node, and in case of height we are counting from the leaf node. Got my point? Fine. Now let's move forward. So these are this is more detailed example I can say. Just an example is given. You can see this diagram. Now in this diagram, how many number of nodes are there? Yes, very good. So now you are having 7 nodes over there. A is the root node kept at level 0. B, C, D, these are the children of A. G is child of C. E and F are children of B. So this tree having level 2. Now A is the root node. B is the parent of E and F. D is sibling of B and C. E and F are children of D. E, F, G, D. These all are the leaves, also called as the external node. A, B, C, non-leaf, also called as the internal node. Then, if you have to find out depth of F. So as I told you, depth is nothing but same as level. So we have to start from root. So root A to B, B to F. So the F is at level 2. Then height of a tree. So height of tree means we have to start from the bottom node, and from bottom node we have to move to the upper node. Wait a minute, students. Hello, am I audible, ma'am?
Yes, ma'am.
Sorry. Okay, sorry for disturbance. So from this diagram, as I told you, E, F, G, and D, these are the external nodes or the leaves. A, B, C, these are the internal nodes. As we have seen, depth of F is 2. Then height of a tree. So as I told you, height means what we have to do, we have to find out the longest path from that node to the leaf node. So when I have to discuss about this F, I can say the path from this node. So longest path. So 1 and 2. So that's why for this F, depth is 2. Height of the tree is 2. So as this is the node, longest node, this is the longest node having depth as 2. So I can say height of the tree is also 2. Then degree of node A is 3. Already we have discussed about degree. Degree means what? Number of children of that node. So for this node A, we are having 3 children. So its degree is 3. And degree of 3. So maximum number of children from this. B is having 2. C is having only 1. So maximum is nothing but 3. So that's why I can say that for A or the for A, as it is having 3 children, the degree of the tree is also 3. Now let's move forward. Now whatever till now we have discussed, there are some trees. A tree we have discussed. So tree having some characteristic. As the characteristic, I can say this is a non-linear data structure. This combine advantages of ordered array. An array whose item have same order are called as the order array. Then searching as fast as in ordered array, insertion and deletion as fast as in linked list. This is simple and fast. So first is, you can say this is a non-linear data structure. Second, it is having all the advantages of ordered array. Here to search any element is easy. Then to insert and delete element is somewhat as fast as we can do in case of linked list. You may have studied that in case of array, it is in case of array for queue, for stack, it is somewhat difficult as it is easy for the link structure. Similarly for tree also it is easy. And this is the fast and simple technique. Now after that, you can see these are the two ways to represent a tree. First, we can see as linked representation. Second is nothing but sequential representation. So maybe when you have studied about the linked list, there you see the difference between linked organization and sequential organization. So basically, previously, as I told you, in case of the basic or the characteristic of tree, I have said that it is nothing but a linked organization. So in linked organization, it is easy to insert, it is easy to relate, because here we can able to allow the memory location. Means if continuous memory is not allowed, then also we can insert the element. And that is the basic difference between the linked representation and sequential representation. So sequential means it is same as the array. It can be the stack, it can be the queue. So you can observe that this is the tree. So this tree can be, when you have to find out the sequential representation, this is the tree. So it is represented as the root node having 2 child node connected with path 2 and 3. Then another children's B, E. So here if this is not connected, so for 6 I can say that here this represents /0, because in this diagram you can see this is the first diagram. So in this first diagram you can see that for node C it is having only one only one child node. So as only one child node is there, this node is not present. So this node is not present means this is nil. Nil means 0. So here the 6th location is given as 0. So you can see, as to represent the sequential representation, you have to convert it into a specific type of a tree, and in that, from that specific type of a tree, which node is absent, we have to mark it as 0. So here again you can say for D. For D you can say 8 and 9 is not there. So here these are also 0. This is nothing but a sequential representation. For link representation, you can observe here. For link representation, what I have done already, as you have discussed about link, here also the link representation. So here, this is nothing but the representation of a tree using linked data structure. Now see, students, here root node represented like this. Now in case of linked list, you have studied about singly linked list and doubly linked list. In case of singly linked list, address of the next node is provided. In case of doubly linked list, it will provide you address of the previous node and address of the next node. So in similar manner here, this is nothing but a node, same as it is used in the doubly linked list. So the middle field represents data, and these two field represents the address of the next node. Now this is very important when you have to see about the program. So here we can see, even you have to write down a C program for writing a representation of a tree, we have to use the same representation. As here we can say, here is the root node having one left node, one right node. So we have to provide address of the left node and address of the right node. Now next move to the B. Now this is the left node. Now again you can observe that for this left node you are having two children. Means here it is having data as D, data as E. So again we can say that it is having left child and right child. That's why left address and right address. Similarly, this B having two children, D and E. But now see, in case of this E, what is there? For E, there is no children's. If no children's are there, I can say both the fields are null. Null means it can be represented by cross, it can be represented by 0, it can be represented as NULL. So from this diagram, you can say that if this is the D, data is D. For this, we are having two nodes given as H and I, represented at left and for right. So address must be provided over here. But here, H is the leaf node, that is the child node. It is not having any further node. So that's why these address field remains null. I think that you must got it. Now see, as I told you, but if now here is your node E, and if for node E only right node is there, then what you have to do? Yes, in that case, we can say that we have to represent address of right node only. We have to keep this left node as null. So I think that you may got it. So as I told you, to write down the program, you have to use this syntax to create a node. So the data type for this is nothing but structure. So I have written as struct node. The data type can be, if I have written as a D. So if numbering are there, then simply I have to represent as integer data. But here if ABCD is there, it must be character data. And we have to create a node at the left hand side, at the right hand side. So I have written as struct node star left, struct node star right. I think that you all got this representation of a tree. Okay, students. Now this is very important. This linked organization is, or the linked representation is very important when you have to see the program. Now, let's move further. So here you can see now similarly means already I have introduced with the tree, but now see I am using the word as binary tree. Now see students, when I am saying as binary tree, we have to focus that for binary tree, there will be 0, 1 or 2 nodes. Listen carefully. I am saying that a node having 0, it can be 1 or it can be 2. Maximum is 2. More than 2 nodes are not allowed. Is called as binary tree. So for binary tree, here if you observe this diagram, A having two nodes, that is two children, B having 2 children, D having 2 children, E having no children, means 0 children, F having 1 children. So this is a representation of a binary tree. So mark up this line as a tree having number of nodes as 0, 1 or 2 is called as binary tree. 3 nodes are not allowed. So this is nothing but a representation of binary tree. It is the structure where no nodes can be more than 2 children. It is a finite set of elements, either empty or partition into 3 disjoint. So there is disjoint. 2 node means it can be the 3 set of 3 A, B, C. Similarly, D, E, B, like this. So this is nothing but a left or right subtree, and that can be empty. So you can see as here it is the for B, it is having left subtree, right subtree, but then the light can be empty. So this is nothing but a binary. Simply from this slide, you have to remember that, you have to study that the tree having number of nodes as 0, 1 or 2 is called as binary tree. More than 2 is not allowed, is called as binary tree. So here it is having 2 nodes, here it is having 0 node, here it is having 1 node, is binary tree. Now, so the same thing is explained. Here is, it is having binary tree that is having only 1 node, only 1 node, or only 0 node. So here no node, no node means in the tree of complete 0 node is there, 1 node is there. Children's are, child is not there. Leaf node are not there, means the combination of only 1. Here are 2, 1 root node and 1 child node. Here it is again 2. Here the child is at left hand, here child is at right hand. And the last is nothing but the root or the tree root node having 2 child node. So binary tree with 1 node, binary tree with 2 node, maybe at left or maybe at right, and binary with 3 nodes, that is left and right, is representation of binary tree. So it is more clear to you now what is binary tree. Got my point? Very good. Here this is again one more example for binary tree. So again similarly you can see in this diagram. So whether this is binary tree, check all the nodes, whether this is a binary tree. Yes, yes, it is a binary tree, because here root node, that is A having 2 children, B having 2 children, E having only 1, D doesn't having any child, C having only right node, F having left and right node. So maximum number of node in this tree for any node is nothing but 0, 1 and 2. That's why it is a 9 node tree called as the binary tree. So if I have drawn one more here, F, if I have drawn one more node over here, and I have given name as J, so then whether it will be a binary tree? No, it is not, because here it is said that for binary tree we must have maximum 2 nodes. 3 are not allowed. Now next, these are the different types of binary tree. First is the full tree, also called as proper, also called as strictly. So full binary tree, proper binary tree, strictly binary tree. Second is complete binary tree. Third is perfect binary tree. And fourth is degenerate binary tree. Now one by one, let us see in detail. Here, as now see student, remember this, I told you that binary tree is nothing but a tree that is having maximum 0, 1, 2 number of nodes. So when it is called as strictly, so it is a special type of a binary tree that have either 0 or 2 children. See what I am saying? It is having 0 or 2. So it is a special kind of binary tree that has either 0 children or 2 children. All the nodes in a strictly binary tree are at degree 0 or 2, never at degree 1. What is degree? Degree is nothing but number of child nodes. So in this way, we can say that here it must have maximum 2 or 0. 1 is not allowed. In strictly binary tree, 1 node is not allowed. Child is not allowed. Children must be there. So to find out the number of leaf node, we can use this formula as number of leaf node is equal to number of internal node plus 1. Moving to complete binary tree. Complete binary tree. Observe it carefully. What you observe from this? Yes, observe it carefully, students. What you observe? For A, we are having 2 child. For B, 2 child. D, 2. E, 2. F, 2. G, 2. Yes, so that is nothing but the complete binary tree. Means a binary tree in which all the leaves are at same level. Complete binary tree having depth D is called as strictly tree if all whose levels are at level D. So all the tree level are filled entirely with the node. What I'm saying, it is filled entirely with the nodes. One is not allowed. Whether 0 is allowed? Yes. 0 is allowed or not? Yes, it is. Because you can observe the last level doesn't have any children over there. So I can say that here H, I, J, K, L, M, N, O, all these are kept at level 3 and level 4 is not allowed. This is nothing but the complete binary tree. Student, note down these things. You have to remember all this. So if I'm saying as complete binary tree, in complete binary tree, all the levels are completely filled. Almost. Now next is nothing but almost complete. So in almost complete binary tree, what I have given over here, here is your tree. This is having 2 nodes. Again, it is having 2 nodes. This is having 2 nodes. See, students, what difference you can see over here? Initially, when you have first that is full, for full I am saying that it is having 0 or 2. For a second, I am saying that all must be at equal level. But 3, that is nearly, almost, name is almost complete binary tree or nearly binary tree. In this nearly binary tree or the complete binary tree, you can observe as these are the tree for which it can be provided with 0 node, it can be with 1 node, it can be with 2 node. But now it is having 0, 1 or 2, means it satisfies the condition for binary tree. But what is the difference? Observe it carefully. When you observe it carefully, for A to D, D to D, and D to H. So I can say that parent D having 2 children, H and I. Here, in the second part, we can say as for A, we are having B, again having D or E, H or I, and J. What you can observe from this diagram? You can see as these are the leaf node and these leaf node are placed in the left hand side. When they are in left hand side, so this is the basic difference you can observe over here. What I'm saying that 1 is allowed, 0 is allowed, 2 is allowed. But the thing is, they must be kept on the left hand side. Right is not allowed. If instead of connecting this to instead of drawing this 2 children, add instead of D, if I have drawn for J, G, then it is not allowed. Then it is not called as the complete binary tree or almost complete binary tree. What my point? Perfect binary tree. So binary tree is said to be perfect if all the internal node have strictly 2 children. Here 0 is not allowed. But you can observe that 0 is not allowed means 0 is allowed only in the last node. So binary tree is said to be perfect if all the internal node have strictly 2 children and every external on leaf node is at the same level or at the same depth within a tree. So for the perfect binary tree, its height is nothing but 2h minus 1 nodes. So this is the representation of perfect binary tree. Got my point? Now last one. That is degenerate binary tree. So in degenerate binary tree, see what happened? This is the binary tree. Why? Because it is having 0, it is having 1 node, it is having 0 node. So when I'm saying that when only 0 or 1 is allowed, then it can be called as the degenerate binary tree. It is called as, wait student, wait for a minute. Hello. So here I am saying that for degenerate binary tree, it is having only 1 node. So for this, A is having 1 node, B is having C is having D. For B, it is B, E, F. Here it is B, E, H. All they are kept at one particular site. So if they are kept at B, it is called as left skewed. If they are connected at the right, it is called as right skewed. So a binary tree is said to be a degenerate binary tree or pathologically binary tree if every internal node have only a single child. So such tree is similar to the linked link performance wise. So this is the example of degenerate binary tree. So got my point? This is degenerate binary. So next is nothing but binary search tree. Now see students, till now you got very well that what is tree, what are the characteristic of tree, what are the types of tree, what is binary tree. Now we have to see about binary search tree. So binary search tree is either empty or in which every node contain a value, means a key, and satisfy the following condition. So what condition is there? All the key in the left subtree of the root are smaller than the key in the root node, and all the key in the right subtree of the root are greater than the root node. The left and right subtree of the root are again binary tree. First thing is it is binary search, means it is binary, means it is having 0, 1, 2. It is not having 3. Now when it is 0, 1, 2, but the special condition is there. Observe it carefully. Observe this one. Here is 50, 30, 60, 25, 40, 35, 70, 65. So let us focus on left hand side. So on left hand side we are having 30, 25, 40, 45, 35. On right hand we are having 60, 70, 65. Okay, similarly, observe this. Here is 8. On left hand we are having 1, 3, 6, 4, 7. On right hand we are having 10, 14, 13. So what is the change, or what is the basic difference, or what is the special observation? Observe it carefully. Observe it carefully. Yes, what you got? Yes. So what you can see students, here these elements are less than 50. So left hand side is less than root and right hand side is more than root. Again observe over here, left hand side is less than root, left hand side is less than root. Here right hand side is more than root, this right hand side is more than root. This binary search. So binary search tree, remember that when left hand side having value less than the root 11, right hand side having values greater than the root 11, then it is called as the binary search tree. You got my point? So the example is given. Now observe this example very carefully. Now see students, what is given? As I told you, for binary search tree, I am saying that all the elements having less than root must be on left hand, and all having higher value are on right hand. So now the list is given. Now see, in your exam, this can be asked for 8 marks. You have to start from the first element. Now observe very carefully and I will explain it to you. So as I'm telling, see, the elements are given as 27, 42, 43, 17, 39, 31, 10, 9, 19, 54, 33, 42. I have to start from each and every element. First, I am having 27. As the first element is 27, it is the root. Next is 42. I have to compare 42 with the root. Remember that comparison must be done with respect to root only. Note down these points. You have to do the comparison with root node only. So here is 27. Next is 42. 42 is greater than 27. So it must be on right hand. So on right hand I have written 42. Now next is 43. 43 is greater than root. It could be right hand. Again on right hand 42. So 42 again means 43 is again greater than. So again it should be on the right hand. Similarly for next element is 17. Again start comparing 17 with the root element. So root element is 27. 17 is less than 27. So if it is less, it should be on left hand. So I kept it on left hand. Next is nothing but 39. So how 39? 39 is nothing but it is greater than 27. So it should be on the right hand. Now right hand we are having 42. So I have to compare it with the 42. 39 is less than 42. So I have to keep it on the left hand side. You got my point? Yes. Good. So next is 31. Now again compare with 27. So when you compare with 27, for 27, it is greater than 27. So come to right hand side. Right hand side we are having 42. So again it is less than 42. Now next we have to compare it with, now less means come to left hand side. So on left hand side we are having 39. So again it is less than 39. So we have to keep it on the left hand of 39. Similarly, do it, observe it for 10. So where 10 is kept, 10 must be kept on the left hand side. Next is for 9. Again it is less. So again left hand side. Now next after 9 we are having 19. So for 19 I can say 19 is, see I will show you one comparison. Here 19 is kept, here 54, then 33 and 48. Now I am showing you for the last element. Observe it carefully. 48. Now you are having this element as 27. Now here is the 27. So you have to compare 48 with 27. Here you are having, means if it is 48 means greater. So come to the right hand. So on right hand you are having 42. So again compare it with 42. 42 having means 48 is greater than 42. So come again to right hand. So again right hand we are having 43. Means it is again greater than 43. So go again to right hand. So there is 54. So for 54, 48 is less. So move to the left hand. What my point, students? Just start comparing with the root element and see whether to left or right. Bus. You have to remember this one. Yes. Good. Next. So here till now I have seen that what are the different types of tree and all that. Now next is nothing but tree traversal. Traversing the tree. Traversal means what? Traversal is nothing but a process to visit all the node of a tree and may print the values. Means to visit every element is called as traversal. So binary search tree is basically binary tree, and therefore it can be traversed in order, pre-order, and post-order. So from this slide, just you have to remember that when you have to do for traversal, traversal means visiting every element, and it can be done using in order, pre-order, and post-order. Now, what is in order, pre-order, post-order? Now see, till now I told you that first is the middle element is the, or the starting element is root, or left hand side element are there and right hand side elements are. So in this, if I am saying about pre-order, root, left, right. In order, left, root, right. Post order, left, right, root. What I am saying, observe this slide carefully. Observe the position of root. When I am saying pre-order, pre means first, means root must be kept first. So when root is kept first, it is called as pre-order. In means at the middle, means root must be in the middle of left and right. Post means what? It can be on the back, post, after. So left, right, and then root. Observe it carefully. I am saying that left at root at first for a pre-order, root at the middle for in order, left root at the right is called as post order, depending on the position of root. I am giving the name as pre-order, in order, and post order. See, I am saying about traversing a tree. Traversing means visiting every element. So to visit every element. So I am now see, I am not writing array. If I am writing array, I am sequentially say as 1, 2, 3, 4 like this. But I am drawing a tree. Tree is a hierarchical manner. So how to represent the tree? Just by drawing, without drawing the diagram, you must able to give the element. So when you have to give the element of a tree without drawing the tree diagram, these are the different ways to write down the elements of a tree. That is pre-order, in order, and post order. So when you have to write down the element, means you have to write every element. That's why it is called as traversal. You got my point? From this slide, you have to remember that to traverse the element, it can be done using pre, in, and post order. If I am keeping root first, it called as pre-order. If I am keeping, wait a student, hello, Jyoti, hello, students, am I audible? Ma'am, you can.
Yes, madam.
Okay, thank you. Hello. Sorry for disturbance. Now am I audible?
Yes, madam.
Thank you. Thank you. Really sorry. Yes. So I'm telling you about the pre-order, in-order, and post-order. Depending on the position of route, I'm saying that whether it is a pre-order, it is in-order or post-order. So accordingly, you can observe over here. If I kept the route initially, it is pre-order. If it is in the middle, it is in-order. If it is at the last, it is called as post-order. So let us see. This is one example of tree traversal. Here, observe it carefully. You can see this diagram. So in this diagram, what you can observe, this is the element 25. This is the root element. So the root element having elements on the left hand, elements on the right hand. When the elements are on the left hand, so these left hand side elements are 15, 10, 22. Again, these elements are kept like this. Now you have to do the traversal. Now see students, you have to listen very, very carefully what I am explaining. I'm saying that अजून एक 15-20 okay, thank you. So hello, now see students, what I'm telling here, I'm saying that here is your root. This is having left hand side, here is the right hand side. So for this left hand and right hand, so you can observe here for this, when I'm following in order. In order means what I'm saying? I'm saying for in order, root is in middle. First I have to do for left, then root, and then right. Now see, I'm not able to do that. Again, I will come to this. Again, this is the root. So again, I have to go to left, then root, then right. Now, but this is again the root. Means again I have to go to left, then root, then right. So as I told you, I have started visiting the element as, see the comparison, focus on in order. So when I'm focusing on in order, this is 25. So for this 25, I will first observe the left. So left is 15, but 15 is again a root. So I have to move to left. So left is 10, but this is again a root. So I have to move to, so first I will write down as 4. Left, then root, then right. So I have written 4, 10, 12. Now move back. Back comes to 15. So left completes. So after completing left, you have to write down root, then come to right. So on right we are having 22. But 22 is again one root. This 22 is root having left and right. So this is the left, then this is the root, and here is the right. So you can observe this. So by observing this, so here you can say as, here I am saying we come from left, root, right, left completes, root, right. On right here is the root. So left, root, right. We comes to 18, 22, 24. So this path complete now. After completing this path now, this completes the complete left. After left, move to the root, and then from root, move to the right. So when you come to right, you can observe here is the right element 15, but it is again a root. So if it is a root, again move to left. So on left, we are having a root. So again move to left. So left is 31, then 35, then 44. Means left, root, right. This completes the left part. Come to root, come to right. Means 66 is left. Here is the root. Here is the right. So this is the in order traversal. Now after in order traversal, next we can say as for the pre-traversal, that is post order. So for what, let us see about the pre-order. So in pre-order, what we can say? For pre-order, observe it carefully. So when I am focusing on pre-order again, so I am doing for pre-order now. Pre-order means in pre-order what I told you. Pre means what? Root come first. So when root come first, so here you can say in this diagram, root is 25. So root comes first. So I have written as root. After writing root, I have to move to left. So on left again, you are having root. So write down root first. So 15 I have written first. Again move to left. Means after root, I have to move to left. So after writing root, I move to left. So again, when I move to left, here is your 10. So here is the 10, means again I am having element as so what I have done here is 10. Here is your root. So move to left. So left is 4. Again move to root, that is 10. Again move to right, that is 12. So in this way, I have done as here root left right, means root left root. So you can see as root again root left right. See, we will come now already. This root is completed. So after this, what you have to do? You have to move this. So in this subtree, what is first? This root is first. So 22 is first. Then left. Then root, left and right. Means 18, 24. So this completes your root and your left part. And then right. So in right again come right part. So for right, what you can observe? Here is your root. So I have written 50 first. Then after writing this 50, I will go to left. So when I will go to left, here you can observe this is 35. So 35 is the root. So I have to write down this 35 as first. Then I have to move after root, I have to move to left. You have to remember the previous slide, because if I'm saying as pre means root, left, right. If I'm saying as post, it is nothing but left, right, and then root. So here I have to focus on right, means root is completed, left is completed, move to the right. So in right again, here is the root. So that is 70. So root first, then left, and then right. This is nothing but the pre-order traversal. See, if you're observing, you're listening carefully, then only you got my point. Otherwise, you have to take pen, pencil, you have to do it your own, then only you will got what I'm saying. If I'm saying that I have to do for pre in order, I have to focus. Every time I have started from the root. If left is there, I will move over here. If right is there, I will move over here. Again, I will check whether it is a root. Again, move to left. Again, move to right. In this way, I have to observe it. So now, if I'm saying about the post order traversal. So for post order traversal, what I'm saying, the sequence is nothing but post order. Yes, means what? Root should be at last. So left, then right, and then root. So come to the left. So here is the root. Come to left. Here is the root. Come to left. So I have left is 4. Right is 12. Root is 10. Move up. After moving up, what you can observe, here is the root. So move to right. So here is the root, left, right, and root. So I have written 18, 24, 22. After completing this, so left is done, right is done, root is there. Now, after 15, where to move? Whether I have to write on 25? Yes? No, not, because I have to write down root last. So by completing this left part, I will move to the right part. So right part is your 50. But it is again a root. So move to left. It is a root. Move to left. So 31 must be written. After 31, 44. After 44, 35. After 35. Now, what I have to do? Yes, from left, I have to move to right. So for right, what I will observe? Here is your root. So here is the left, right, and root. 66, 90, 70. Then come to root. Then come to root. Students, you may little bit confused, but if you do your own, then only you will got this point. Nothing very difficult, just you have to focus, just you have to note down, means in order, root middle, pre-order root first, post-order root last. And just you have to observe every element, visit every element, you can easily do it. Nothing difficult in it. Only you have to focus it, you have to concentrate in, you can easily do it. Yes, good. So similarly, now the next thing is, till now what we have done the binary search tree, we have done the tree traversal. Now this question may be asked, and there may be some question as the pre-order or in order, post order is given, and then you have to draw the tree. Previously what we have done, tree is given, and from tree you have to write down in order and post order. But if in order and pre or post order is given, and then you must able to draw the tree. So very simple example I have taken it for you. See, in this example, in order is given as A, B, C, D, E, F. Post order is given as A, B, C, D, E. So in order and post order is there. So for in order and post order as given, accordingly you have to write down. So sorry, here pre-order is given. Here by mistake I have written post order. You have to focus as it is pre-order. So if it is pre-order like this, what is the first element? First element is, now focus mainly, we will focus on pre-order. So in pre-order, what we are doing? See, students, don't focus on this red line, focus on this one. So what? See my arrow where I'm showing. So I'm saying here is your pre-order. Pre-order first element is A. So first element is A, means your root must be A. So after A, B, C, D, E. So all these are the values that are greater than A. So greater means on which side? On right hand side. So I kept all this on right hand side. So B, C, D, E on right hand. Now next element is B. So B is more than D or greater than D. Alphabetically I am checking. So B is over here on the right hand. So D, E, F again on the right hand. So C is on right hand, D is on right hand, E is on right hand. So instead of starting with A, B, C, D, if I started from B, so if B is there and after B if A comes, then what I have to do? Yes, just I have to draw it on the right hand, left hand side. Very good. So this is nothing but the representation. So this I have done for ABCD. Now next you can see. Now I think this diagram is not properly visible, but just focus what I am saying. Just to focus on my word, you will got my point. So here again, here the order is given, post order is given, and from post order now you have to draw the tree. Now see the elements are given as 5, 16, 5, 17, 19, 18, 10, 17, then 85 means 8 and 5, 60 and 10. So these are the post order. So students, as I told you, this is a binary search tree. So binary search tree, what is the main condition? For binary search tree, the condition is that the element on the left hand side are less, element on right hand side are more. So here I have to write down its in order. So in order is written because in order what we are saying, if you write down the in order, it is a increasing order. You try for any example. The condition is you have to do it for binary search tree only. So for binary search tree, if you are done the in order, then you can simply observe that it is nothing but the elements arranged in ascending order. So whatever order is given, arrange the element in ascending order. After arranging the element in ascending order, observe it. So you have one element, means now here focus on both these. So I am focusing on post order and I am focusing on in order. So in case of post order, what I am saying, for post order means last element is, tell me, for post order last element is, yes, it is root. So root comes last in post order. So here the last element is 20. So that's why 20 is the root node. So 20 I have written over here. Now focus on in order. So in order, what will happen? 20 kept over here. All these are the lower element. These are the higher element. So lower means on the left hand side. Higher means at the right hand side. Got my point? So this first step completes. Level 1 complete. Now we are playing again. Means level 0, level 1 like that. So we come to level 1. Now moving to next. So I have to see for this one. So when I have to see whatever your remaining elements are there, again I have to find the root node. So to find out the root node, I go to post order. So when I have to focus on the post order, I have to observe that 15, 16, 17, 18, 19. So from these left side elements, I have to find out the root element. So for this, to finding the root element, I have to again focus on the post order, and for post order, I have to move by right to left. So here 60 greater, 85 greater, 70 greater, they all are at the right hand. So next comes 16. So as we know, for post order, root comes last, means here is the 16. So next would be 16. Got my point, students? See, you have to focus on it. We have to do it very carefully. I'm saying that I'm focusing on in order and I'm focusing on post order. To find out the root, I am seeing for the post order. To keep the element, I am focusing on in order. So accordingly, so yeah, I kept this 16 over here. So after keeping 16, what I have to do? Now I have to move to in order. So again, it will categorize into lower element and higher element. So 5 is lower. So lower means it should be on the left hand. So I kept this 5 over here. What about these? These are on the right hand. So right hand side elements are nothing but 17, 18, 19. So what is next? Yes, what is next? Right, I have to go to the post order. So for post order, now what I have to do? Again, I have to find out the root node. Means again, I have to move from right to left. So after 16, there is 18. So that's why the root element is 18. Now after getting 18, now I have to see the less elements. Means the elements that are kept on the left and they are on the right. So 17 is less. So it is on the left. 19 is greater. Keep it on right. Similarly this way. Now observe it carefully. See students, focus on my words, then only we'll got it. Then only you can able to understand what I am saying. See, I have moved to right hand side. For right hand side now I am having 60, 70, 85. So 60, 70, 85. First element is your 60. How I have to find out the root. So to find out the root, I have to move from right to left. So after 20, next element is 60. Means root is now 60. So focus on the in order. So in order, you can see the remaining two elements are greater. So since these elements are greater, I have to keep it on the right hand side. There is no element on the left hand because no element is there less than 60. So here is no element. Both the element are 70 and 85. So 70, 85 kept over here. Now to find out the root, what I have to do? Yes, I have to move to post order. So I move to post order over here. So here is your 85. So means 85 is the first element. That's why I have to keep this 85 as the root element. And after 85, who remains? Only 70 remains. So as 70 remains, you have to compare 70 with 85. 70 is less. That's why keep it on the left hand side. So I'm sharing this PPT. You have to focus on this, or you can easily got this these solution in your textbook also. You can easily understood it if you got my point. Okay, thank you. Next. So last point is nothing but representation of or the program for creating a tree and tree traversal. Ma'am, स्वाती मॅम.
येस मॅडम.
आता कंटाळा आला असेल का मुलांना? का ठीक आहे?
मॅम फक्त कोड घेऊन फिनिश केलं तरी चालेल.
हो, येस येस, संपलंच आता. मी फास्ट घेते.
हो हो.
Okay, now see students, here is the program for creating a tree and tree traversal. So if theoretically you got it, then it is easy to write a program. So as I told you, here is your tree and here is nothing but link representation of a tree. As I told you, if this is the root node, it is having right side, left side, it is having right side, means you have to provide address of the left node, address of the right node, right? So I have shown I have to provide address for this one. Similarly for this also. Similarly for this also. But for E, what happened? It is the leaf node. So no address on the left and right. Now see. See here in this program, initially as we know, we have to include standard input output. We have to clear the space and we have to include standard. Then here the data type is nothing but structure. So I have to write down as type definition struct node. Now here if characters are there, I have to write down character data. If integer is there, I have to write down integer data. Now I am using node. This is nothing but a node. This is node. This is node. So if I am providing node, this node is on left hand side and it is on right hand side. So I am saying L child. What this star indicates? Star indicates the pointer. So pointer for left side, pointer for right side. And this is nothing but a structure node. So if you carefully done the program for linked list, the same structure I am using over here. Now next is we have to provide these different functions. So I have written create, in order, pre-order, and post order. Now again, if we want, we can find out the element also. So here I have to write down function for in order, pre-order, post order, and search. So I have started the program as here void main. I have to give different input as choice, X and S. X is the value. Meanwhile, in the program, I will tell you. X is nothing but the keyword that is used to search the element. X is means the data that we have to enter. And choice means which part we have to do. Means whether we have to create, whether we have to pre-order, post-order. That options we have to provide. That's why choice is given over here. So void main integer choice X comma S. Then what I am doing initially, I have to create first node. So that's why I have written as node star root. Now what I have to do? I have to do as whether I have to provide which particular operation. So create in order, pre-order, post-order, search, or if not any, then press 6, that is for exit. Now you enter the choice, you have to scan it. Then accordingly you will move to that particular function. So here these different cases are provided. Case 1 for create, case 2 in order, case 3 pre-order, case 4 post order, and if the number is to be searched, then you have to enter the number to be searched. So that we have to give as S. Now for search, I am directly written operation over here. See, if search is there, so if X is equal to 1, means if you got the element, then if it is there, so you have to say number is found. If it is not, then simply you have to print as else number is not found in the tree. So, and otherwise you have to exit. Means choice, you have to move to the exit. That exit is nothing but if choice is equal to 6, you have to close the loop. This is the program where I have just entered the choice which part is to be performed. Now I am providing, search is also done over here. Huh? Search is also done over here. Now I am doing function for everyone. So first function is for create. So when create means, again focus on the first diagram where I have shown you the link structure. So in link structure, what is required? See, you have to enter the data. You have to move the loop number of times, because now depending on number of nodes you have to create, this value n you have to do. For loop requires I, and flag should be initialized. Flag means it is just a default value where you have to move. So that's why the flag is written. Now node, because every time we are using the node. So first of all, let us use as a root node. To create new node, we are using new node, and then temp variable, because we have to shift it from each digit. And as I'm seeing here, if you have to go for in order, pre-order, post order, what you have to do, you have to move from left to the previous. So when you have to move to the left to previous, means it again require another variable or pointer. See, simply I can say that temp and previous, these two are the pointer that are just used to move the location of that particular data. Now see students, if you got a program of singly linked list and doubly linked list, then only you will get this logic. Now after this, what I'm saying, initially I have said that root is equal to 1. And then number of element what I have entered. So I have what that value I have to give. Now I have to move the loop. So by moving the loop, whatever number of element I have now, this will move in this particular loop according to the number of element I have created. So initially I have to create a node. So as you know, in case of, as I told you, this is a linked data structure. In linked data structure, we have to provide memory dynamically. As dynamic memory is to be provided, here we have to use my function. So to create a new node, the data type is a node. Using malloc function, you have to provide. This is simply, we can say, as a representation or creation of the new node. Now, after creating the new node, so you have to enter the data. So new node, link data, the data is entered as X. So whether you are put as the left child or right child. So initially, if your element is root, means it is not having left child, it is not having right child. That's why we have to initialize this as a null. So if root is equal to null, then you have to create the loop and you have to stop over here. Otherwise what you have to do, this is just creation of the root node. Now root node is created. Otherwise, here what we have written here, if root is equal to null. Now if it is null, then you have to create new node using this function. Now it is not, means it goes in the false part, means it will go in the else part. So in else part, what you have to do, whatever root you have created, you have to assign that value as pointer temporary. So in temporary, now this is, we can say as this is nothing but same as the recursion. Recursion means what? Calling the same loop repeatedly. So means you have to do on left hand side and you have to do on right hand side. So for that I have created a, means I have represented a temporary variable or temporary pointer for that. So when your temporary equal to null. So if your temporary equal to null means initially you have to create the first node. After creating the first node, what we have to do? We have to move check whether it is equal to null or not. If it is not, then let us assign it as previous. So if it is previous, so whatever is your data provided for temporary, that you have to store in the X node, and then your left child we have to assign. So whatever data you have to enter, that will move in the left hand side of your tree, and otherwise whatever is the element that move to the right hand. So here is the principle of recursion that you have to understand. So using that, what we are doing, just we are assigning the variable. By assigning the variable, you have to enter the data, and by entering the data, you have to move the data in left hand and in right hand. So if it is in flag 1, means you at the left hand side you have to create new node, and if it is on the right hand side, on right hand side you have to create the new node. So by calling this function, that is means we are calling this as new node. So for creating the new node, again it will move to the this function. So what I am doing here in this particular function, I am calling this. That's why it is a recursion. So when I am saying as L child, it will move to this part, means for the L child, it will go for the new node creation, and new node creation means it will move to the new node. That new node is connected or created on the left hand side. Otherwise, it is on the right hand side. So this is the left hand element as L child, right hand element as the right child. So this previous temporary, these are nothing but the pointers that are used to represent that particular location. So this is just the expression of create function. Now see in pre-order. So for pre-order, you can see in pre-order we are saying that it is nothing but root, left and right. So what this is nothing but the function. That function is represented written for the pre-order. So for pre-order, again I can say as you have to provide the node that is in the temporary variable. If it is not null, then you have to assign the data. After assigning the data, as we know that here initially in pre-order, here is your temp variable, means your initially you are writing the temp, means that temp is nothing but your root, as already we have written in the program. So it will write down your root element first, and then it will move to left child, and then it will move to right child. Temp means it is a storing node. At node we have stored these values. Data means your root node value. L child means here you have stored the value in the temporary pointer on the left hand side and for the right hand side. So you can observe this diagram. So by observing this diagram, you can say as your root element is A, then you have to go for pre-order of B, you have to go for pre-order of C. So in pre-order of P, I am saying as it will again move to the D, again pre-order of E. So see, this representation as already I have explained. I have directly shown you the output. But in your theory paper, you have to write down this question for 5 marks, and this answer is for 5 marks. So in this way, you have to explain it. So this is for pre-order. Now similarly for now you can observe carefully that in order we have kept the data in temporary variable first, then left and right child. So if I am showing that for post order, so for post order what is there? Root should be last. So temp I have written at the last. First is the left child, then right child, and the root. Similarly for the in order. So in order what I am doing? For in order I am saying that data comes in middle. First is the left child, then is the right child, and then data comes. This is representation of in order and post order. So last element is nothing but last point is nothing but deleting a node. So to delete element, the 3 categories are there. I can delete the element having only leaf node. So for leaf node directly I can remove the element. So 4 is directly remove this diagram. Next is nothing but I can able to delete the element that is having a node as only one child. So you can observe this element as 18. 18 having only one child node. So only one child node means simply I can remove this path. By removing this path directly, I can connect this 21 at the place of 18. So you can see that 18 is removed and 21 connected like this. And the last is nothing but it may have, as binary search tree is there, it is at maybe leaf node, it may be having only one child, it may be having 2 child. So when 2 child are there, the 2 ways are there to delete the element. That is using predecessor and using successor. So if I am doing for predecessor, so see in this example, this is in order predecessor. So in order predecessor means what I have to do? I have to find out the largest element from that subtree. So here you can observe this diagram. Here is your 15. So for 15 now the key element is given as 20. Means you have to delete 20. So when you have to delete 20, you have to observe 20. 20 having 2 subnodes, means 2 nodes. So to child node. So it is 18 and it is 30. So we have to observe this subtree. I am observing the subtree that is present on the here for this particular means here I am saying that I have to delete 20. That is nothing but if I have to follow the predecessor. So to find out the predecessor means I have to find out the largest element from the left subtree. So this is your left subtree. So from this left subtree, you have to observe the highest element. So here again means see when I have to delete the node that is having 2 children in this diagram, if I have to delete 20, I have to focus on that particular part. So when I focus this here in order predecessor node means here just I have to copy 19 from this. So I have to focus on this part. Means what? 16, 18 and 19. Here is your 20 I have to delete. So to delete 20, I have to focus on the left part. See what I'm saying. I have to delete 20. So focusing on left hand side. So on left hand side now I am having 19 as the largest element. So just I am taking 19 over here and remove the remaining. This is for the predecessor. And for successor, I have to find out the smallest element. Suppose this, I have to remove this 40. So to remove the 40, now I have to focus on the right part. So in the right part now, I have to focus on the element that is having lowest value. Previously, left hand, highest value. Right hand, smallest value. So from the right hand side, yeah, the smallest value is 50. So I have to just keep 50 over here and delete the remaining. So this is the last operation that we can perform on trees. So there are the different applications of tree that can be used, and this is all. Thank you so much. Thank you, ma'am. Thank you, students, for your patient listening. And I think that some points means it is it must be beneficial for you. Thank you so much. Thank you, ma'am.
Thank you very much, ma'am. It was really very beneficial for the students. And you have explained very well and in a very simple language so that student can understand. I hope the students have understood the topic. And thank you very much for accepting our invitation and delivering such a good session.
Okay,
Thank you.
thank you so much, ma'am. Now I'm will end the session. Okay.
Yes. Yes.
Okay,
Yes.
I'm
Thank
leaving the
you.
meeting. Thank you so much. Thank you, students. Thank you.
Thank you.